Hey, let's see how we calculate the correlation coefficient. What I wanted you to do here is calculate the standard deviation of W and Z using the linear relationship. So, standard deviation of W will be 1.8 times 15. And the standard deviation of Z would be this number divided by 1000. Right? That's what we learned in chapter 4. So when you multiply 1.8, standard deviation will be increased by the same ratio. However, addition does not change the standard deviation. That was the point. Once you calculate the standard deviation of W and Z, then you can calculate the covariance divided by those standard deviations. And actually we know the answer because we already got minus 0.7559, and as I explained the intuition, the correlation coefficient should be the same. A. You will get the same number. Let me show you on Excel. So I'm going to calculate I'm going to calculate standard deviation of W, standard deviation of Z. Standard deviation of W is 1.8. It is 1.8 times standard deviation of X, so which is 1.8 times 15. And standard deviation of Z is standard deviation of Y divided by 1000, which is let me see if it's correct. 13229 divided by 1000, and the covariance between W and Z is minus 270. So the correlation coefficient is minus 270 minus 270 divided by this and this. Then you get minus 0.75592, right? This is how we calculate the correlation coefficient. So, and we verified, we find that the correlation coefficient is the same as before the transformation and after the transformation. The correlation coefficients are the same. I already did it. Okay, I read it. You use the standard deviation, then you will get the same number. So again, let me summarize. Covariance captures the direction using by its sign, but its absolute value has no meaning. The strength is not captured. However, correlation coefficient is more useful in the sense that the direction is captured by its sign and its absolute value is the strength of the relationship. So, correlation coefficient contains useful information to summarize the relationship between two variables. Okay, then let me show you how we use it. So this is the data we considered: average yearly temperature and GDP per capita. Let's see how we calculate the covariance. So when you type covariance formula, as you see, there are two options: covariance.p and covariance.s. P means population, S means sample. So population formula or sample formula, but let's try both. So when you choose covariance.p, and I'm going to drag one random variable, and then comma, and then drag the second variable. So column B is the first array, column C is the second array, and enter. Then the covariance P is minus 3,036 minus 36,653. Let me increase the right. And covariance, if you try covariance.s, then you do the same thing. Choose the data. Oops. Then you obtain a different number. Though it's different, it is quite similar, because the only difference is whether the denominator is 183 or 182, right? So that's the only difference. And as the sample size increases, the difference is negligible. So that's the difference. And to calculate the correlation coefficient, let me do an experiment. I'm going to calculate standard deviation dot p for the first variable. The standard deviation of temperature is 8 point something, 8.24, and standard deviation dot p is this guy. So this is the standard deviation for GDP per capita. It's 14,000. By the way, they are using population formula. Observe this, .p, I used .p. So correlation coefficient, I am going to calculate the covariance, population covariance divided by the multiplication of two standard deviations. You get minus 0.310. That is the correlation coefficient. Correlation coefficient using population formula. As an experiment, I am going to calculate sample standard deviation. Sample standard deviation for both, and recalculate the correlation coefficient using sample formula. This is the same. No matter what you use, sample formula or population formula, the result should be the same. So when you calculate the covariance or standard deviation, it matters whether you use n-1 or n. But when you standardize the covariance to correlation, the denominator will be cancelled out. So it does not matter. This is the correlation coefficient. Or simply in one step, you may use this function, CORREL, correlation between this guy and this guy. The correlation is exactly the same. Should be the same, right? The three guys are the same correlation coefficient. We have the same guys. And I'm going to compare that with Fahrenheit case. I am not going to do everything, but let's simply calculate correlation coefficient. Correlation coefficient using temperature in Fahrenheit and GDP. I did not change GDP. It's simply GDP per capita in dollars, not in $1,000. Let's just do the same thing. So if you change the unit to Fahrenheit, still the correlation coefficient is the same. So compare this to this guy, right? As expected, as they should be. The correlation coefficient is calculated this way. Okay. I am going to consider another example in the next video, and I hope it helps. And you may use Excel in homework, so it will be quite easy to handle the homework now. Okay, good luck. See you later.